And here on our GitHub repository, as you scroll down on the landing page, it has our README file, which covers the abstract, what the code does, the prerequisites for installation, and the quick start guide. There is a script, do everything.sh, that automates the processes. Now, initializing a Bayesian network with empirical distributions from synthetic data is a novel use of Cynthia's outputs. Research can use these models to investigate relationships between different variables, such as symptoms, pathology, age, and gender, that are complicated and perhaps counterintuitive. And we'll walk you through our app here as you see it on the screen. Once you finish running the code and the Python Flask initiates a simple app interface that we created, it'll list all the potential symptoms that you can choose from. Of course, if you choose an odd pairing of symptoms, there will be no results, as Synthia doesn't generate any that means there is no medical records that had that combination of symptoms. For example, if we choose fever and a 35-year-old female and a empirical Bayes network, then the results will come up with this interaction. And here you're going to see that the pathology conditional probabilities based on her having that fever are represented. And so she could have viral sinusitis. That's the highest probability, most likely outcome. But you see even a urinary tract infection produces fevers in a 35-year-old female. Now, as you investigate further and you see the pathologies, you see beyond the top five, and you see any pathology that has fever as a symptom, down to strep, sore throat. If you wanted to look at the highest probability here, viral sinusitis, what are some other symptoms associated with that? Then you can click on it and it'll be linked into the other conditional probabilities so fever again gives you the 40%, and the cough is there at 43%. You also are going to see the severity distribution here based on how severe. So if the patient is very severe versus not as much, and you also see the distribution here. Now, if you wanted to use the application to test for multiple symptoms, in the first example, we tested for fever. Now we're testing for a fever and a cough in a 35-year-old female, and we're going to do the Bayesian network. Now, when you click on the Bayesian network, it's going to take a little bit longer than the empirical because it's building the graph and constructs the factor graph and propagates the sum product algorithm to all the nodes. This makes it take a few more minutes longer. But as you see in the results here, now the probabilities are going to be slightly different as we use the Bayesian network construction to construct the conditional probabilities are associated with fever. Then again, you can click on fever only, and you see top five there. And then you also see the severity distribution amongst the other disorders. As you see, as you scroll over, you get the nice call out menu that then gives you the pathology, the severity, and the probability density, which here you're going to see 3 of them as a 0 most likely outcome, and 2 of them that have more than that when you get up into the 40 realm of severity. Validation models. We wrote the test to validate that the consistency of the Bayesian network model is there, and then we also validated the outputs against existing tools. Using WebMD, we showed results very similar to the Synthia analysis, but some Synthia modules aren't producing symptoms and therefore don't show up. Simple checks like this can be very useful in validating Synthia outputs. Now we have demonstrated a useful technique for Synthia healthcare records. These techniques can be used to help physicians in their complete care, providing complete care of the patient. They can help them to identify symptoms and which symptoms would be higher probability of an outcome, and give the patient a choice, right? If the patient doesn't want an invasive surgery to identify a lump or a mass, then we could identify other symptoms associated with a potential diagnosis of that patient, taking into consideration the patient's needs.